This lesson is on special right triangles and super important concept as we do trigonometry. So you want to make sure that if you have any questions, you find me and ask. Okay, first we're going to review how to use the Pythagorean theorem to find the missing side. And so as you remember, we would do leg squared plus leg squared equals hypotenuse squared. So remember, your hypotenuse is always the largest side. We are going to leave our answers as radicals. And so you're going to have 100 minus 25, so x squared equals 75. Take the square root of both sides. Now when you take the square root of both sides, remember we do plus or minus, but because we're talking about the side of a triangle, the negative doesn't make any sense. So it's just going to be 5 square root 3, and that would be the missing side of your triangle. So we would say BC equals. And with the notation on this, we would say BC with no line over the top of it, because we're talking about the length of a segment. Okay, the second problem, we are going to do the same thing. We're going to do 12 square root 3, and we're going to square that, plus x squared is equal to 24 squared. So 576 is equal to, that's going to be 12 times 12, and then times 3. The 3 comes from square root 3 times square root of 3. So that's going to be 432. And we're going to subtract that from both sides. So we'll have x squared is equal to 144. And so x is equal to plus or minus 12, but because we're talking about the side of a triangle, again, we would say that BC equals 12. Okay, and then the next one, let's use the trig ratios that we learned last time to find the missing sides. So I'm going to find the hypotenuse, and I'm going to find this side right down here. So let's just use angle A, and we just need to focus on one thing at a time. We can't find both of those at the same time. So I'm going to say that the tangent of 30 degrees is equal to opposite over adjacent. Now you could choose a different ratio. Again, it's just about the perspective. So if you wanted to use the 60-degree angle, you could. It just depends on where you're looking at. So I'm just going to choose to do this one. I would multiply both sides. Now make sure your calculator is in degree mode, because remember that that does make a difference. And then we are going to get the answer. And so y is going to equal 10. And so now that we know that that's 10, we actually could use the Pythagorean theorem if we wanted. We could also use another trig ratio to find x. If it doesn't involve rounding anything, then using the Pythagorean theorem is fine. So I could say 10 squared plus 10 square root 3 squared equals x squared. So that's 100 plus 300 equals x squared. And so x squared equals 400, and x is equal to plus or minus 20, so of course just 20. And so that's one way to do it. We also, as I mentioned, we could use another trig ratio to do that. We could say sine 30 is equal to, actually we won't do sine on that one. We can say sine 60 is equal to opposite over hypotenuse. And so then again, thinking about proportions and such, it's going to end up being x is equal to 10 square root 3 divided by sine 60. And so you're going to put that in your calculator, and you'll find out that we actually have the same thing as what we did the other way. It doesn't matter, x is equal to 20. So do you notice any patterns here? So first of all, look at the 3 triangles on this page and look at the similarities in the triangles. So if you notice that each of the triangles is what we call a 30, 60, 90 triangle, because all of the angles are the same. So all of these triangles are similar. They're not congruent, but they're similar because they're 30, 60, 90 triangles. So if we label all of the lengths of the sides, let me just take everything off and we're just going to label the sides. So this one is 10 and this one is 20. And then this one is 5 square root 3, and then this one was 12. So do you notice any patterns? So pause the video for a second and look and see if you see any patterns that you notice. Okay, so one thing hopefully you notice is that on each of these triangles, if you look at the shorter leg and the hypotenuse, the shorter leg and the hypotenuse, do you notice anything? So the shorter leg is half the length of the hypotenuse. Now there's actually one other thing to notice here, and so I don't know if you knew it, if you noticed it. Let me erase what I've got here. Just uncircle this stuff. If you notice the two legs, so look at the shorter leg compared to the longer leg. Shorter leg compared to the longer leg, and shorter leg compared to the longer leg. If you take square root 3 times the shorter leg, you get the longer leg. And that is always going to be true in a 30, 60, 90 triangle. And so that's something to remember because that's one of the characteristics of these special triangles that we're going to want to know. All right, let's look at the next set of problems. We're going to use the Pythagorean theorem to find the missing sides of each right triangle. So you can go ahead and pause the video, work through it, and we'll just see if you get the right answer. Okay, if you notice, like, I'm only giving you one side of the triangle, and so how do you find one of the sides? Well, if you notice, these are isosceles triangles, so this is going to be 6. So then you would do 6 squared plus 6 squared equals x squared. So this is going to be square root 72, which when you simplify that down, it's going to be 6 square root 2. Okay, this one, if this is 45 degrees and this is also 45 degrees, so you're going to have 14 squared plus 14 squared. And that's going to equal 196 times 2. That's 392. Take the square root of that, and we're going to want to simplify the radical. So if you square root, both sides and you simplify the radical, you're going to end up with 14 square root 2. And then on the third one, again, we've got 45 and 45. So these two are the same. Now, I don't know what they are, but I do know that whatever they are, they're the same. And I know that that's equal to the hypotenuse squared. So I'm going to have 2x squared equals 4 times 2, which is 8. Divide both sides by 2, and I get x squared equals 4. And so x is going to equal 2. Okay, so if we look at what we notice on these triangles, these are called 45, 45, 90 degree triangles. And this is the other kind of special right triangle. And there are some characteristics. So I'm going to put in all the things that we just found out. This one, it's a little bit easier to see the pattern. So we already know that the two legs are the same because it's an isosceles triangle. But what to notice is that the hypotenuse is the leg times square root 2. And that's always true with the 45, 45, 90 triangle. So we're going to say that the legs are the same. And the leg times the square root of 2 is equal to the hypotenuse. Probably shouldn't abbreviate that. Okay, so let's go to the next part of this and get some definitions written down or some things that we want to make sure we know. So there are two types of special right triangles, a 30, 60, 90 and a 45, 45, 90. The special properties of these triangles are, in a 30, 60, 90 triangle, the hypotenuse is twice the shorter leg. Okay, and the shorter leg is opposite the 30-degree angle because remember the smallest angle is opposite the smallest leg. And the longer leg is opposite the 60-degree angle is 2 times the shorter leg. In a 45, 45, 90 triangle, the legs are congruent and the hypotenuse is square root 2 times the leg. And then we can also say, it works the other way. So if you know the hypotenuse, you would divide it by square root of 2 to get the leg on a 45, 45, 90. So let's put this into practice and do some practice problems. We're going to find the missing links. You're welcome to pause the video and work it out and just make sure you know it and you understand as you need to. So fill in what you know. So this is 10 and 10. It's a 45, 45, 90 triangle. So if you know the pattern, you just take the leg and you multiply it by square root of 2. And there you go. You're done. You don't have to work out the Pythagorean theorem. Sorry. Okay, and then the next one's a 30, 60, 90. And I know that because this is 60 and this is 90 and then this is 30. So I can see that I've got the shorter leg, and so if I double it, I'm going to have the hypotenuse. And then if I multiply it by square root 3, then I'm going to have the longer leg. And I'm just noticing, hold on, I'm just noticing that on the previous page, okay, sorry, this one, the longer leg is actually square root 3 times the shorter leg. There we go. Sorry about that, fix that. Okay, so let's go to the next set of problems. So number 3, 30, 60, 90. So here's the hypotenuse. If I take half of that, I'm going to have the shorter leg, because that's the 30 degrees. So then if I take the shorter leg times the square root of 3, I have the longer leg, and I'm done. So if you know this pattern, it sure saves a lot of time. So in the next one, we've got an isosceles right triangle, so 4 square root 2, and that's isosceles there. And then remember, to get the hypotenuse, we're going to take the leg, and we're going to multiply by square root 2. So square root 2 times square root of 2 is 2, times 4, this is 8. Okay, the next one, 30, 60, 90 triangle, so notice what kind of triangle you're dealing with. Then look at what the information is that we give you. So if you're given the longer leg, so I know that if I take the longer leg and I divide it by the square root of 3, then I'm going to have the shorter leg. And then if I take that and multiply it by 2, I get the hypotenuse. Now you can always check any of this by putting it in your calculator with the Pythagorean theorem and seeing that 9/2 squared plus this number squared is equal to 81. And so that's kind of a nice thing that you can do to check it. Okay, number 6 is also a 30, 60, 90. 7 is going to be your shorter leg, so 14 is your hypotenuse, and 7 square root 3 is your longer leg. And so it's really that simple. There's not a lot of work to show here. Just make sure that you're using the right ratios. And then this next one, number 7, is a 45, 45, 90. So we've got 2 on that leg. And then we do 2 times the square root of 2 for our hypotenuse. Number 8, 45, 45, 90. So make sure that you're not mixing up the two triangles. This is an isosceles. Then we're going to take 2 square root 10, and we're going to multiply by the square root of 2 to get my hypotenuse. So it's 2 square root 20. You need to simplify that radical. So it's going to be 4 square root 5 when you get all done. Okay, so you can pause that and go back and look at that if you need to look at it some more. Make sure you understand how to get the right answers. Okay, so this can go the other way too if we need to find the measure of an angle of our triangle. So how many degrees is that? We can use the special right triangles too, using our trig ratios. So this is kind of related more to what we did last time. So if we're trying to find this angle right here, I'm given the side opposite and the side adjacent. So I can say the tangent of x is equal to the side opposite over the side adjacent. I need to solve for x. So since I need to solve for x, I can't split up the tangent and the x because remember that they're connected. So what I can do is I can use my calculator and I use this button. And what that means is it means for what angle is the tangent 14/20ths. And so that's what you type in your calculator. So tangent -1, which is the inverse of the tangent, which means what angle has the tangent, and then you're going to put in 14 divided by 20, and then it's going to come out with 34.99. So this angle right here is, it says to the nearest degree, so we're going to say 35 degrees. And then if that's 35 and this is 90, then I can figure out what that angle is too. So if you look at number 10, if I'm trying to find this angle, I've got opposite and I've got hypotenuse, so that's going to be sine. So I'd say sine x is equal to opposite over hypotenuse. And so I'd say for what angle is the sine? 37 over 43. And so I put that in my calculator, and I will be able to find the angle that that is true for. And that's going to be approximately 59 degrees. It's 59.369, but it says round to nearest degree, so 59 degrees. Okay, I'm given the side opposite and adjacent to the angle in a question, so which ratio should I use? So opposite and adjacent, that's going to be tangent. Okay, and that's how I figure out number 9. And so number 10, the one up above, the reason why we used sine is because we had opposite over hypotenuse. And so that's how we figure that out. So you need to make sure that you understand which ratio you're supposed to be using. Okay, and last, depending on what I'm given, we can still find the missing angle, and I can use more than one choice. I've got more than one choice to do this. So if I'm trying to find this angle, I've got all 3 sides, so I can say, okay, then the sine of x is equal to 56 over 70, so I can do the inverse sine 56 over 70. I could have said the tangent of x is equal to 56 over 42, and I can use that ratio. I can use cosine. So I've got a lot of options there, and so you can use any of those to find out what you need to find out. So that missing angle is 53 degrees. And then for the last problem, again, look at your options. So I could say the sine of x is equal to opposite over hypotenuse, or I could say the tangent of x is equal to opposite over adjacent, or I could say the cosine of x is equal to adjacent over hypotenuse. And I can use any of those to find out what I need to find out. And it doesn't matter, you should have, whoops, this is 78, you should have the same thing either way, and you can double check it by doing a couple different ways. So this would be 22.6 degrees, so we will call that 23 degrees. Okay, so just to emphasize again, this special right triangle is super important. We're going to be using it over and over and over, so make sure that you understand. If there's any questions, please let me know.